Hello and welcome to another part of this video tutorial. Before I continue the walkthrough of the Explain-Ash output, I would like to make another attempt at explaining something that I have already tried to explain in the previous parts, but maybe haven't made that obvious. So what I'm talking about is the difference between these figures that you see in many different places in the Explain-Ash output, which are called something like total and active. For example, this duration seconds total and duration seconds active. And I already explained in the previous parts that the total figure is based on the ash samples from first to last sample that is found. In this particular case, it's actually based on SQL exec start to last sample, and the active part, like duration active and average active sessions active and so on, is based on all sample points, active session history sample points, where at least one sample was found. So if almost for every sample between first and last sample you have at least one active sample, then there is no big difference between total and active. Like for instance here we have 51 seconds total duration and 49 seconds of 49 sample points where we actually found activity. So there is no big difference, and therefore the difference between those two is not really relevant in that context. However, there could be cases where these two are actually quite different. And then I try to explain why could these be different. Well, the most obvious difference could be true application think time, so that the application, while performing a fetch during a select, actually thinks about the data, so has application side think time. So the database is then simply not active during that period. It could also be related to network activities, so that you might have some network issues or high latencies for whatever reason, like a wide area network connectivity, something like that, where you also have then significant time spent outside the database. So that is one obvious explanation why the total and the active figures could be quite different. But there are also other possible reasons. Another possible reason is that that I haven't mentioned before, is that possibly your active session history source simply doesn't cover all samples. So if you have a SQL exec start for a query that, for instance, started more than 2 hours ago and is a very long running query, so it's still running after 2 hours, and maybe your $$ active session history only covers the last hour, then there simply will be a gap of 1 hour between the first sample that is found in active session history, because it simply covers only the most recent hour, and the SQL exec start of the query, which was 2 hours ago. So that is another case where simply the instrumentation information is missing, and which could also be an explanation why the active and total figures are different. So if you have such cases where the source is not covering, where the source doesn't cover the whole execution duration, then this is another reason why these total and active could be different. And sometimes you can simply solve this issue in Explain-Ash by then switching to a different ash source, like DBA hist active sesh history, which then covers the whole period. Yeah. And the third reason why you might have this difference between total and active is that there might be different SQL IDs in the ash samples for this particular session during this period that is analyzed. Typically this would be recursive SQL activity, so other SQL gets executed in a recursive manner, and is then basically belongs to the activity of the main SQL execution that explain-ash analyzes. But there is also the possibility that you have different SQL executions that are actually not belonging to the SQL execution analyzed. So in case of a query and the fetch phase, the same session could have open many different cursors and could fetch some rows from one cursor and then fetch some rows from the other cursor. So you do not have, and you don't have necessarily the recursive pattern in order to have then different SQL IDs in the ash samples for the total duration of the SQL execution analyzed. So this is probably not that common, that case that you have one session that fetches from different cursors, but it's technically possible. And from the real-time SQL monitoring point of view, these two different cases can be differentiated because the real-time SQL monitoring is based on built-in instrumentation. So real-time SQL monitoring knows whether the SQL execution that is currently taking place is actual recursive activity or whether it's a different SQL ID that is not recursive activity. Whereas in looking from that from active session history point of view at such a pattern, there is no clear separation possible between these two cases, because in active session history you simply see two different or many different SQL IDs. You see then no clear relationship between these SQL IDs, although there is this top level SQL ID, as I've already explained in previous parts of the tutorial. If you happen to have multiple levels of recursion, then this top level SQL ID no longer allows you to tell whether these different SQL IDs spotted are actually recursive activities or not. So so that's the most common case for different SQL IDs during the execution duration of the main SQL ID is then typically recursive, true recursive activity, and that might be maybe the most common case that you get something like that in the active session history. And that leads me to the next section that I actually want to cover in this tutorial, which is here this other session, which is the summary of the session's other activity, which is, as I outlined in the initial part of the tutorial, is the section which is about different SQL IDs that were found in the active session history samples during the period analyzed. And in many cases you probably will then see an output like this here that explain-ash tells you I haven't seen any other SQL ID, and all samples analyzed, all active session history samples analyzed are actually about this main SQL ID here, that is this main SQL execution that is analyzed. But it's also possible to end up with a different pattern, which would then look like this here. So this is a recursive SQL activity pattern, and we can see this here that in the explain-ash output, the first indicator that here something is different is that we see here the significant difference between the total duration and the active duration. So we have more than 1 minute of total duration, but we only have 30 seconds, only 30 samples in VDOL active session history in this case, only 30 samples of activity that can be related to these main SQL execution that gets just analyzed. And of course, from this output alone, you cannot tell yet whether what reason actually, which of these reasons that I've just outlined is actually causing this difference between total and active. But at least you can see here that something is here, that there is a big difference between these 2. Since we have in this case the real-time SQL monitoring summary, we can actually tell that in this case it is about recursive activity, because the duration and the database time recorded in the real-time SQL monitoring tells us that the whole execution duration is covered by actual database time. So in this case it cannot be the it can neither be the case of application think time, because then the database time would be less than the duration, and it can also not be the case of different cursors activity of the same session, because then again the database time for this particular SQL execution here would be less. So it has to be recursive activity, but since Explain-Ash can also be used without the real-time SQL monitoring information, if we assume that this section here was missing, then we would be left with just this here, and then we would have to look further if we can see some indication in the remaining Explain-Ash output whether we can tell what kind of stuff we are actually looking at. So just to give you an idea, so we have here this average active session total and average active sessions active, which is as I said based on the same idea. So the average active sessions are for the total duration is only 0.5, so only half on average, only half a session is active during the total duration, whereas if you look at the activity of the checking only the sample points where at least one session was active, then we get an average active sessions value of 1, which of course is in this case the least value that you could get for average active sessions active, because at least one sample point has to be active. But in case of parallel execution, you could of course have higher values than just 1. Yeah, so again here you can spot here the significant difference between these two values. And now we see here, if we now check this next section, this summary of the session's other activity, we can see here that from first sample to last sample of other activity we have a duration of 53 seconds, and within this 53 seconds we had actually 35 seconds, 35 samples in this case of actual activity. So, and we can see here already that these two values together, these 30 seconds here and this 35 seconds here, in this particular case very well fit these 65 seconds of total activity. So this already gives us an idea, so that this is the activity of the main SQL, and this activity here, then this 35 seconds are then either, since I cannot tell this, cannot separate this clearly, this is then either activity of recursive type, or it is actually activity of a different cursor. So that would still be possible by simply looking at the active session history information. As I said, you cannot differentiate these two cases, whereas here from real-time SQL monitoring I can. So yeah, so we now see here this some more information about this other activity. This is a global summary, so you see again here something like the number of samples for $$ active session history. This corresponds exactly to the activity here. If it was parallel execution, then of course it could also be a much higher sample count than the percentage of CPU activity, in this case 100%, 35 out of 35 samples were CPU activity, which again gives us approximately 0.5 average active sessions total for this other activity. And again the average active sessions active is 1, the middle value is 1, minimum and maximum active is also 1, and so on. No parallel activity in this case, otherwise the same idea would apply here that I've already explained for the global summary of the main SQL execution analyzed. And with these counts, you have to be a little bit careful. These counts are not absolute counts, but these are counts based on the samples. So you always have to put these counts into relation to the number of samples found. So this means, in this particular case, within these 35 samples found for other SQL IDs, there was exactly one unique process identifier found, no transactions were found, 2 different SQL IDs, 30 different SQL executions within these 35 samples, which of course doesn't necessarily mean that there were only 30 executions, but maybe potentially millions of executions. But for these 35 samples, 30 different SQL executions could be identified, and the same idea applies to number of modules found in these samples, number of different actions found in the samples, and so on. And we have again these from 11.2. We have here these why no yes no indicators, describing in more detail what kind of activity was sampled in these active session history samples. Yeah, so that is what you then see if there are any other SQL IDs found in the samples during the execution of the main SQL. And if there is anything to tell about this other activity, if I just go back to this here, then you will see this next section following is already this global ash summary. Whereas if there is something if there is some other activity, then this other activity details section will show up, which simply will miss in case there is no other activity, which makes sense because it won't show anything anyway, so it can simply be skipped in that case. But in this case here, since we have other activity, we get now here at a top to bottom analysis, which means those that come first are most relevant in that sense. So that's the idea here. So they are basically just ordered by sample count descending. So that's the idea. So we see here now the SQL ID, if there is a SQL ID in these corresponding active session history samples, and along with the SQL text, if it could be found in the corresponding SQL text source, then the top level SQL ID. In this case, I only have one level of recursion, so this is then actually the main SQL here. So in this case, we can actually tell from the top level SQL ID that it is recursive activity. But as I already said, if you have multiple levels of recursion, then this is no longer possible using this top level SQL ID. So then we get an idea about when did this SQL ID first show up, when was the last time in the samples that the SQL ID showed up. Then in relation to the main SQL execution, this means in this case here, right from the first sample, this different SQL ID was found, so we can verify this. So the first sample was found here at 182634, and this is then actually corresponds to the SQL exec start. So this is the meaning of this one here, that it just tells you, okay, this first sample is how many seconds since the start of the main SQL execution analyzed. And likewise here, this 36 for this no SQL ID case here, which is also covered, then was then 3 seconds at the third second after start of the main SQL execution. Then total and active is again the same. So what is the duration based on first sample to last sample, and for how many samples within this first sample to last sample there was actual activity that can be related to this SQL ID. In this case, this were 31 seconds, 31 samples, which were again 100% CPU, and the same things that I already pointed out above, so I don't need to explain them again. What I find quite helpful is this time active graph. So the idea of this time active graph here is that in relation to the main SQL execution, you get an idea when was this particular SQL ID in was this showing up in the corresponding hash samples. So since this was quite significantly active, it showed almost up all the time. So this is basically the graph basically starts with the execution of the main SQL and ends with the last sample that is sampled for the main SQL execution. It could still be running, so you can of course use explain hash on a still executing statement. So this would then correspond to the last sample, and this is then a graphical indicator when this particular SQL ID was found in these active session history samples. So this was obviously during the most recent samples, this SQL ID here was not found, and this case here where we do not have any SQL ID at all was only sampled 4 times. So we can see here the pattern. It was sampled sometime towards the beginning of the main SQL execution, then here towards the 1/3 or towards half of the sampled period, and then sometime here again it was. So that's the idea of this time active graph, so that you get a picture of the activity pattern, and then again we have here these already explained flags indicating the type of activity. Yeah, so these 2 sections allow you to get more details. If there is some other activity in the active session history samples found, it gives you here the summary and then this details, and which is then ordered by these most relevant SQL IDs first. And yeah, as I already said, you can't really, in this case you can, because due to this top-level SQL ID, but in most cases you cannot really tell from active session history alone whether this is true recursive activity or some other cursor activity. But I think in many cases it will be recursive activity, because this fetching from different cursors intermittently is probably not a very common activity pattern anyway. Here that we have here a corresponding real-time SQL monitoring report for such recursive activity. We can see here that again, this is this 65 seconds of total duration with 65 seconds of database time. So this is about the same execution, this report here. And the critical part for recursive activity, or to differentiate in terms of real-time SQL monitoring, to differentiate between recursive and non-recursive activity. In case of recursive activity, you see here, of course, that in these summaries that this database time corresponds to the duration in most cases. But you will see here in this activity tab, you will see here this SQL ID showing up. So this is not the typical, usually you would see here I/O or concurrency and so on, but in this case a different indicator shows up for the different SQL IDs found in the active session history samples. And since this is basically part of this activity here, you can see here, spot here from this activity tab, you can see here this recursive activity in this case. And if it wasn't recursive activity, then I think you would see here the SQL ID, but it wouldn't be part of the execution time here. So it would simply show up as no activity, but the SQL ID would still be shown. I think I'm not entirely sure off the top of my head, but that I think is the way the real-time SQL monitoring would graphically allow you to tell the difference between these 2 cases.